Hi everyone! Today we will be talking about defense against infectious diseases, aka defense against the dark arts.
How exciting! We'll be discussing about what causes diseases such as pathogens, the roles of skin and mucous membranes in defense against the pathogens, the second line of defense such as phagocytic leukocytes, and the process of blood clotting.
A pathogen is a disease-causing microorganism or a virus or a prion.
Secondly, we must outline the role of skin and mucous membranes in defense against pathogens.
The skin is a dry and tough region of the body made up of dead surface cells for external protection around the body. It contains biochemical agents such as sebaceous glands that secrete chemicals which inhibit the growth of bacteria, and they also release acidic secretions to lower the pH to also prevent bacterial growth.
So, what are mucous membranes?
Mucous membranes protect the internal structure. For example, what we see in the trachea. It is a thin region containing living surface cells that release fluids to wash away pathogens. They contain biochemical defense against agents, and mucous membranes may be ciliated to aid in the removal of pathogens.
Thirdly, Shinwan, would you like to explain how phagocytic leukocytes ingest pathogens in blood and body tissues?
Why yes, I would be delighted to. Phagocytic leukocytes are part of the second line of defense of pathogenic invasion. They mainly circulate in the blood, but they may move into body tissue in response to infection. This process is called extravasation. They concentrate on sites of infection as a result of the release of chemicals from damaged body cells. They then go through a process called endocytosis, by which large substances or bulk amounts of smaller substances enter the cell without traveling across the plasma membrane. And it is very important in the ingestion of pathogens. Jana, I don't know where to go from here. Can you please give me a hand?
Of course! Pathogens are engulfed with cellular extensions such as pseudopodia, surround the pathogen and they fuse, sequestering it in an internal vesicle.
Oh no! I just got a cut from this very sharp ruler and now I'm gonna bleed to death.
But Shinwan, no fear, because our body blood clots. Okay, now what is blood clotting? Blood clotting, also known as hemostasis, is the prevention of bleeding and maintenance of blood volume. More specifically, it prevents the loss of blood from broken vessels and an invasion of bacteria and pathogens into exposed blood. An example of blood clotting is an example of metabolic pathways. In other words, a chain of biochemical reactions.
Damaged cells and platelets release chemical signals called clotting factors, which trigger coagulation cascade or production of thrombin.
What is the process of blood clotting? It first begins with the clotting factors converting the inactive synovial prothrombin into the activated enzyme thrombin, just as John had explained previously. Thrombin then catalyzes the conversion of the soluble fibrinogen in the blood plasma into insoluble fibrin. Then fibrin forms a sort of insoluble mesh or net of fibers that effectively trap blood cells in the blood vessels at the site of damage. Now, the insoluble mesh of fibers act as a solid plug, and it is made of sticky platelets that stick to the damaged regions of the blood vessels. Now, in summary, blood clotting begins with cell damage or platelet damage, which activates the clotting factors and thrombin to be produced, which then catalyzes the process of soluble fibrinogen into insoluble fibrin, which then captures the erythrocytes or red blood cells and creates a blood clot. Shinny, you won't be bleeding so much after all.
Yay! Wow guys, our body does such a great job in defending us against infectious diseases.
or the dark arts.
We hope that you enjoyed this very much.
Thank you. Bye.